All right, everyone. Thank you very much for joining us. Looks like we have more than 50, approaching 60 people joining us today for our monthly seminar. This month's seminar is in regard to protecting critical electronics from failure. And this really covers a broad range of areas for our customers with pure air filtration. So I'm going to jump right into it. And I'll mention to you a few things. If you could, please mute if you're not already, please do mute your microphone in case your telephone goes off or anything to that degree. There is a question and answer forum that you can check at the bottom of your screen. So at the end of this, if you have a question, type that question in there, and we'll respond to those at the end of the seminar, just so that we're not talking over each other. Yeah, if there's any other issues or questions, certainly send us a chat through Zoom. Anyway, my name is Kevin James, and I'm president at Pure Air Filtration. We're located in Atlanta, Georgia. I appreciate everybody's attendance today, and hopefully you're going to walk away from this learning a little bit about gas phase filtration and how to protect your critical electronics from failure. So let's get started. Well, so just as an introductory in regard to pure air filtration, we actually work in 4 categories, kind of four different markets or 4 different applications. Today, we're really just going to focus on this one, protection of mission critical electronics from hardware failure. I'll mention the other 3 just really briefly today. Let me turn on my laser pointer. There we go. I'll mention the other one today, odor control and environmental emissions control. So this is mainly for wastewater treatment plants, but also for industrial or kitchen exhaust, preventing odors and gases from escaping areas, for either for reducing complaints from neighbors or for environmental compliance. Indoor air quality, that's protecting the air inside of buildings from gaseous contaminants. Typically airports, museums, where we're protecting precious works of art, and other applications, even just office buildings where you're looking to improve your air quality for personnel inside. The last area just generally mention is emergency gas scrubbers. So in this case, we make standby systems. We provide standby systems, very, very low maintenance standby systems, which activate in the case of an emergency gas release and capture that gas and protect people and equipment from that. So, but today we're going to be speaking about protection of mission critical electronics from hardware failure. So let's jump right into that. So one of our mottos here is Pure Air is a world leader in the removal of gases, odors, and vapors. And how do we do that? We do that through a technology referred to as gas phase filtration. So everybody's hearing a lot of talk these days about filtration in regard to the whole COVID crisis. Everybody, if you didn't know what a HEPA filter was before, you certainly know what it is now. And so filtration is certainly getting a lot of focus, and we're certainly enjoying a lot of that. Let's say general focus on filtration, though we don't necessarily have specific things for viral control, at least yet. We do think that's something coming out soon. So in regard to gas phase filtration, our technology and products protect mission critical electronics from corrosion. All right, this corrosion, as you can see in this photograph here, can be very harmful. So especially as electronics become smaller and smaller and our dependency on electronics become more and more critical, these types of issues can cause really big problems. So industrial facilities, wastewater treatment plants, data centers, all really have very, very critical electronics, and even the smallest electronic failure can cause some really huge headaches in any of these facilities. So we work on filtering out those harmful gases to prevent these issues from occurring. This corrosion is typically caused by some type of harmful gas, and we'll discuss some of those gases and what we do for that. So in regard to filtration, I mentioned HEPA filtration. It's got a lot of attention here. So HEPA filtration is really great at removing dust and smoke, and to some extent bacteria, and there's some discussion about viruses, probably not capturing actual viruses, but at least capturing the droplets that viruses are in. So if we're talking about filtration of dust and smoke, the size of those particles are typically 0.03 to 100 microns in size. All right, so 0.03 microns, pretty small stuff, and you can get HEPA filters which will capture that type of size particle. If we're talking about liquids, vapors, mist, I'm talking about basically fog-sized particles where you can't necessarily see the individual particle, but in the distance altogether you can see it. These are about 1 to 9 microns, and there's other types of filtration that can capture these liquids and vapors and mist. In our case, we're also removing particles, but we're removing individual molecules. All right, so while dust and smoke may be small particles, they're comprised of probably millions of each dust particle is composed of millions of molecules. So we're talking about taking out gases which are 0.0003 to 0.007 microns in size. These are ultra small particles. In fact, we're taking out individual molecules out of the air. And so sometimes we have customers that say, well, we have a bad gas that we need to take out, so we'll just put a HEPA filter in there because HEPA filter captures everything. Well, gases pass right through HEPA filters, just like air passes right through HEPA filters. And so that's a misnomer that some people might have in regard to HEPA filters. So these gases have to be, when they do have to be captured, they have to use a different type of technology to do it, and that's what our expertise is in. And so we're removing these molecules of gas from the air. It can't be done through mechanical filtration. Some of the gases we're talking about, hydrogen sulfide, sulfur dioxide, ammonia, chlorine, volatile organics, and we use this. We use a technology referred to as gas phase filtration or chemical adsorbents. We use adsorbent medias to take these gases out. So here's an illustration of how this looks. Basically, we pass gas through an adsorbent media. We'll get a little more detail of this. This is adsorbent media, captures these gases, and purified air comes out the back end of it. So the key is these adsorbent media that we produce here in Atlanta. We produce different types. And this is an illustration of one type of a system and configuration that might be used in some of these cases. So how does this technology work? Well, we focus on the principles of adsorption and chemisorption. So to help explain that, I want to focus that there are two words up here that look very, very similar. There's absorption with a B, and there's adsorption with a D. So absorption is actually, there are two very similar concepts, but I want to mention to you that we're focusing on adsorption. And adsorption is when molecules are brought into an adsorbent and bound onto the inside of an adsorbent. So it's a lot like a sponge, right? So as water is pulled into a sponge, it's bound into that sponge and it's held in there. So our adsorbent are like little tiny sponges of sorts where the gases can go in, and they're bound inside of the adsorbent. And one very common adsorbent is activated carbon. I think a lot of people are very familiar with activated carbon. Maybe you have an activated carbon filter in your water filter, or maybe you have activated carbon in a home air purifier with this. And activated carbon is a very good product for catching general gases, and these gases kind of go inside the pores of the activated carbon where they're bound in there. Well, the problem with adsorption, like this sponge, if you take the sponge and you adsorb the water into the sponge, let's say there's water on a table, you take a dry sponge and you put that dry sponge into the water adsorbs into the sponge, but you can squeeze that sponge and the water will then come back out. Well, that's a process we refer to as desorption. And it's just the opposite of adsorption. The gases come back out of the adsorbent. And while that can be useful in certain applications, in most of the applications that PureAir works with, that's very, very detrimental. And that's why activated carbon, plain activated carbon, is typically we don't use in very many applications, because our customers typically require 99.9% type efficiency. And if you have an adsorbent, which is occasionally desorbing these gases, and the desorption occurs for lots of different reasons, changes in pressures and temperatures and humidities, but the desorption occurs, and it's harmful. So for most of our products, we work with a subgroup of adsorbents called chemisorbents. Chemisorbents are adsorbents with a chemical modification made to the adsorbent, so that when the gases go into the adsorbent, they're chemically modified, typically turned into a solid, and they are bound in the inside of this adsorbent, and they cannot be unbound. All right, so it's a permanent reaction, and it gives our product a very, very, very high efficiency in regard to the capture of these odors. The one disadvantage in regard to this is that chemisorbents, once they are fully consumed, cannot be regenerated. So plain activated carbon you might hear about can capture odors, and then you can send the activated carbon through a special process. Maybe you have to send it out to be processed, or maybe you've got the equipment on hand to go through a regeneration cycle where you can basically desorb all the gases out of the activated carbon and then reuse the activated carbon. So there are some filters even in your car and your automobile which do that, use activated carbon for capturing gasoline vapors and such. And so that can be a very useful function. For our customers that are expecting the high removal efficiencies, we use chemisorbents. When the chemisorbent is completely consumed, it needs to be replaced. So in this seminar, we're going to be talking about how we use that technology to protect mission critical electronics. So industrial processing facilities such as pulp mills and petrochemical refineries produce various byproducts which can be harmful to electronics. In the pulp and paper mills, there's chemicals that are used to process especially the pulping area, which can be very, very detrimental to electronics. The high humidity in that environment is also important. The same issue goes on with the petrochemical and refinery industry, where typically desulfurization of fuels is creating environments which can be corrosive to electronics, to the copper and the silver inside electronics. You can see a photo here of electronics which have been severely corroded. And I'll also mention to you that wastewater treatment plants, especially this is important for our water and wastewater sales representatives, wastewater treatment plants are also a key. So that odor, which is created at wastewater treatment plants from the natural process of digestion and such from that, if you can smell the odor at a wastewater treatment plant, it is there's a significant process of corrosion occurring of any kind of electronics. So of course you're probably familiar with the wastewater treatment plants, that things rust very quickly. If steel rusts quickly, or if stainless steel even is affected by it, then certainly electronics are. Another area is certainly data centers, especially data centers in very urban environments where maybe there aren't very good automotive exhaust controls or industrial controls, typically developing countries' data centers. So even relatively small levels of gases can corrode the copper and silver and other metals in this electronic equipment. So just think, you've got these very, very small circuits. These circuits are typically made of a silver solder. They typically have copper circuit paths in there or other copper electronics. And I'll mention to you, in prior years, there's been a push for it's called the RoHS regulations, removal of hazardous substance, where in the effort to remove lead from and other hazardous substance from the general use, most lead has been removed from a lot of solder in the electronics industry. Well, that lead provided some protection against electronics. And so now the lead-free solder is extremely susceptible to corrosion. And we've seen just a really huge increase in the amount of corrosion after the implementation of the RoHS standards to remove lead from electronics. So that's something where you may have seen an increase in the amount of failures of electronics after this RoHS regulations were put in place. So how many items in a mill, refinery, data center, wastewater treatment plant ever outlive their warranties? So the key is, in some of these and many of these facilities, the electronics that are provided by big companies like Honeywell and such typically have a statement deep in the warranty, which indicates that the environment has to be suitable to the electronics. And so we have worked with a number of cases where manufacturers of electronics did not honor the warranty of electronics because they had huge failure rates at facilities. And when they looked into it, they found out that the environment was extremely corrosive to the electronics. And there was, of course, a big battle in regard to it, because the manufacturers claimed that the electronics weren't being properly protected. So properly protecting electronics prevents unplanned downtime. It prevents replacement of equipment prematurely, and it allows manufacturers, paper mills, refineries, data centers to be free to do what they're intended to do, rather than tracking down electronic failures and dealing with loss in productivity. So here's just some different areas where you might experience some corrosive gas effects. Control rooms, absolutely critical. Often the control rooms are right next to the process which they are controlling, and sometimes those processes have some very corrosive gases. So control rooms are almost always purified in these corrosive environments. Motor control centers, especially as motor control centers are using more and more variable frequency drives. These variable frequency drives are basically small computers that are adjusting the voltage and the frequency in order to control the motors. So these small computers have small circuits, and they do corrode. And so we very often run into customers who say, oh no, we don't allow for any use of variable frequency drives because of their poor reliability. Well, it's because that reliability is typically related to gaseous contaminants that are causing some type of failure of the variable frequency drive. So if we can fix that gaseous contaminant, then we can fix the reliability problem of the variable frequency drive. Also laboratories, laboratories are very often, especially at a paper mill or a refinery, where we're checking various levels in the laboratory. They're often getting some hydrogen sulfide released in there, and we see work with some customers that have some very, very expensive lab equipment, which fail very, very quickly. You know, we see some of this lab equipment easily costing $20,000, and they're replacing it every year because it's failing with it. So it's you know, a simple solution to fix this and prevent that type of failure. So there are lots of things to consider, and we're not going to go into any kind of detail about looking at the solution on how to solve the airflow, the air quality in an electronic environment. But these are just some of the areas that we take a look at. You know, what is the type of contaminant and the level of contaminant of gas that's in there. Of course, that's one of the most important things to take a look at. What kind of airflows and do we need to take a look at with the HVAC system in there? Temperature and humidity are really, really important factors to consider because they affect the rate of corrosion. We can take a look at pressurization or recirculation in order to solve the problem. Pressurization is a really nice thing to be able to have, but it's not always easy to do that. Typically, it's a much bigger project to install pressurization in the existing system. So we can very often rely on recirculation systems to solve the problem. Lots of issues with space restriction. Nobody has extra room sitting around to be able to take systems. So we very often have to put systems on top of roofs or up in ceilings or something. Important factors to consider: the building construction. Is it a well-sealed room or is it not? How often are people coming in and out of the room? How often are doors being opened? We also want to take a look at particulate filtration. And once we get the system in place, how do we know that it's working properly? So keep in mind, our technology, we take invisible polluted air and we purify it, and out comes invisible purified air. So how do we know when the system's working and when the system needs to be maintained? So we'll discuss that here real briefly. So the basis of this work is from the International Society for Automation. This used to be called the Instrument Society of America, and they renamed it years ago to the International Society for Automation. I sit on this committee for the ISA 71 committee. There's a standard that was written originally in 1985, and it was revised just slightly in 2013. And this standard basically provides a method and 4 classifications for measuring your air quality. And it has a very simple test. The simple test basically provides for the use of a pure copper and a pure silver strip. Here's an example of what our test strip looks like. It's very often called a corrosion classification coupon. So in our industry, you'll hear this discussion of coupons, and it's just a pure copper, pure silver strip. We have a nice little plastic cover over it so that people don't touch it and invalidate the results. And that strip is left in the air in the affected space for 30 days. On average 30 days, but it can be left in a little bit less or a little bit more as long as you document how long it's in. And then that sample is sent back to our laboratory, where we do a coulometric reduction in our laboratory on that sample and actually reverse the corrosion and electronically. And by reversing that corrosion electronically, we can actually measure the amount of corrosion and also the type of corrosion, what caused it, sulfides or chlorides or oxides, in order to give a good analysis of what has occurred during that 30 days. All right, and the ISA standard comes up with these 4 categories. G1 is mild, and that's what we're targeting for. That's the least corrosive for electronics. And there's a G2, G3, and GX, which is severe. And these are some guidelines that the ISA standard gives for a general level of gases that might be in those areas with it. So the key I want to point out is hydrogen sulfide. This is one of the gases that we focus on the most. In order to maintain a G1 environment, we have to maintain 3 parts per billion of hydrogen sulfide. look at, for chlorine, it's 1 part per billion. So this is a real challenge, and this is why we have to use our chemisorbents rather than adsorbents, because if an adsorbent is occasionally releasing or desorbing a little bit of the gas that it captured, well, that you're never going to be able to maintain 1 part per billion or 3 part per billion. And so that's why our adsorbents have to have this ultra efficiency and permanency to their work. So here's an example of what one of these coupons looks like before and after. So as you can see, we have basically a mirror finish to the copper and to the silver prior to testing. And then afterwards, this is a coupon that comes back, and you can see the corrosion, the tarnishing, which occurred over that 30-day period. And I can assure you, this isn't the most severe that we ever see. This is probably a G3. Just by looking at it, I can with 20 years experience, I'm kind of look at it and tell you that's about a G3 application. So it's certainly not a good environment, but it's not the worst of those. Sometimes we come back and you can't even, these are just completely black. You can't even tell what's that they were copper or silver prior to that. So this is a simple test. We provide these corrosion coupon testings to customers all over the world. Is a very simple test, very low cost, and allows the customer to get an idea of what's happening. Again, it's an invisible problem. We know that the corrosion is occurring, but we have to get a handle on somehow on how to define where that, what's causing that problem, what level of problem is. So we provide this coupon, we provide a report back, and then we can work with our customers to develop the right kind of solution for that. So in regard to the standard, I'll also mention just a couple of things. I alluded to this earlier, but the control of temperature and humidity is really, really important, and is focused on in the standard as well. So while our systems don't necessarily control the temperature or humidity of the room, we're concentrating more on capturing the gaseous and to some extent the particulates in the air as well. It's very, very important that we also are taking a look at humidity control and temperature control, because any humidity above 50% is really creating a problem, and it basically accentuates the problem with the gaseous contaminants. So to give you an idea on why that's the case, hydrogen sulfide itself is somewhat corrosive, but the real problem occurs when a hydrogen sulfide molecule combines with a water molecule and turns into sulfuric acid, and that sulfuric acid comes down onto the electronics and causes the corrosion. So if we can control the amount of water droplets or humidity, not water droplets, but water molecules that are in the air, then we can control the amount of sulfuric acid that is created, and we can reduce the corrosion. So we want to keep that humidity level below 50%. It reduces the potential for corrosion. And of course, we want to get rid of as much gas as possible. And also, going back to your chemistry days, any increase in temperature increases a chemical reaction. That's what corrosion is. It's a chemical reaction. So if we can keep that temperature reduced, and that's typically involves dehumidification as well. Whole temperature control and humidity control are related. But if we can keep that under control, then we can reduce the corrosion. Also, the standard does discuss pressurization versus recirculation. And pressurization is a great thing to be able to have. The standard is typically recommending pressurizing the room with purified air. So typically taking the outside air, purifying it with a PureAir system, sending it into the HVAC system to cool and dehumidify it, and then pressurizing the room with just a slight amount of pressurization, anywhere from 0.05 inches of water column to 0.1 inches of water column. So that's just 12 to 25 pascals. I'll mention to you, overpressurization can be actually very harmful because it can create temperature and humidity problems. So you just want a little bit of pressurization to make sure that when somebody's opening a door, that gases aren't coming from the outside into the inside, or that gases aren't coming in through cracks in the walls and such. So just a little bit of pressurization. If you can't have pressurization because you have an existing building, the HVAC system won't take the additional load, then we can very often take care of the problem with just some pretty heavy-duty recirculation systems. So we have a lot of systems that can just be placed into the room and just recirculate the air over and over and over again. Sometimes it's hard to get to exactly a G1 with a recirculation, but we can certainly make some huge improvements. Maybe taking a GX to a G2, maybe to a G1, just depending on the application there, but certainly making some huge improvements in the corrosive nature of the environment there. Just a little more information, particulate filtration is important as well. You don't want all that dust collecting inside of your electronics. Our systems typically do have very high efficiency dust filters in them as well. So we do take care of that dust filtration at the same time, though that's really just an accessory. The main focus is really focusing on the gas absorption. We're also working with our customers to understand the construction, more understanding about the room itself. Every room that we work with is different. It might be very well sealed up room. It might be poorly, a very porous construction with it. And so typically a well sealed room can be more easily fixed than a room that isn't very well sealed. And we also provide sealing services for rooms in many cases. So when it comes to air purification, this is examples of what some of the equipment looks like. So we'll just mention to you, there's kind of two types of systems. There's deep bed systems, and this is an example of a deep bed system. A deep bed system is filled with our loose adsorbent media, and so the air is drawn through the adsorbent media, and the gases are captured in what's called this deep bed. So this would be basically a 3-foot or a 1 meter deep bed of adsorbent, and that's a traditional, very, very heavy-duty solution. Certainly, the choice technology for a GX environment, going to have long-lasting, really high-efficiency system, but these are very expensive systems and very large systems as well. So there are, in addition to deep bed systems, there are cassette type systems. Here's a nice example of a system. I believe this is a system we provided into Abu Dhabi, offshore oil rig. And here there are cassettes that are in place. And these cassettes, let's see if I can show you a picture of a cassette here. These cassettes are pre-filled with the adsorbent media, and they don't have quite the efficiency of a deep bed system, but you can have multiple sets of these cassettes in series, and they provide the level of efficiency needed based on the number of cassettes. So if it's typically we have two types of cassettes. We have a PP18, a PP12, and typically a PP18 is a medium duty cassette. It can improve your air 1G level, and a PP12 can improve it 2 levels. So if you need to make 3 improvements, then you might have to have 2 or 3 passes of these cassettes in order to get to that area. So again, going back to deep bed systems, this is kind of what this deep bed system looks like. We can actually have multiple adsorbent medias. If you have multiple gas types that have to be removed, we might have to provide multiple adsorbent media types. So that's a adsorbent, that's a example of the deep bed system. Blower on this side. Typically we're drawing through the air in the system and then purifying it with 1 or 2 different media types and then exhausting it out. In this case, this is a deep bed system for odor control where we're exhausting to the environment. For protecting electronics, we would typically be pushing that air in to pressurize a room space. Also, recirculation system. These are a couple examples of a small recirculation system. This is our PFU Mini. This is a small roll in the room unit in case you've got a problem that needs to be addressed right now. This is basically an off-the-shelf unit that you can roll into the room to provide some immediate remediation of the problem. And then we have some larger systems that can fit into the corner of the room and provide a lot of recirculation as well. So this is what a typical recirculation system might look like inside of a control room. Here's the the PP18 cassette and the PP12 cassette. So this is what would be referred to as a medium duty cassette and a heavy duty cassette. So typically improvement of at least 1 G level here, improvement of about 2 G levels there. Again, cassettes are not going to last as long as a deep bed system will, but they do operate at a much higher velocity. And so they allow you to shrink the size of the unit, shrink your initial capital outlay as well too. So really great solutions for cassettes as long as they're configured properly. In regard to adsorbent medias, we have lots and lots of adsorbent medias, all manufactured here in our facility in Atlanta. So we have adsorbent medias of lots of different shapes and colors. Probably one of the ones that we're most famous for is this permanganate impregnated alumina. We offer this in 4, 8, and 12 concentrations. 4 is the original, 8 is kind of a standard in the industry, and 12 we developed a few years back as the kind of leading edge technology. And basically these just have a longer life. For the PureAir 12 is basically 3 times longer in life than the PureAir 4. So there's some really great advantages for customers, especially in these cassettes where you have less adsorbent media in the system. If it lasts longer, then it's a really great benefit. Lots of carbon-based adsorbents. We do use some plain activated carbon for some applications where some volatile organics might be used. That's where activated carbon itself works very well. We have a catalytic carbon with a capacity for hydrogen sulfide of 66% by weight. It's like a hydrogen sulfide sponge. Some other products, low cost hydrogen sulfide scavenger, our Self-Absorb FE, and we also provide a lot of blended products. For protecting electronics, I can tell you that the product that is typically going to be working the best overall for most customers is our PP blend. This is a combination of our Self-Absorb media and our PureAir 8 media. It's a multifunctional product which captures basically all of the corrosive gas families. And so if you don't know exactly what gases you have, use PP blend and it'll take care of the issue. It's our default for all of our protecting electronic applications. Here's a little bit of information. We'll have this available to you. We can send it to you by email, but this is just some good information about different adsorbents and where they can be used well for VOC capture or sulfur compound capture, etc. So, and just general cost of usage. So we can provide that to you afterwards. If you shoot us an email, we'll send you this presentation for you to take a look at. Now, the key is, I mentioned to you earlier, we work in a very unusual industry where we take an invisible pollution and we purify it, and out comes invisible purified air. So how do we know whether it's working or not? Well, we talked about the coupon. So just as you can use this corrosion classification coupon to identify the level of problem that you have, you can also use this to monitor your system long term. So periodically you can put a new coupon in place and just check to make sure everything's going okay. Well, that's very nice and it's a low cost way to do it, but it is a bit inconvenient in that you have to order the coupon, you then have to place the coupon, you have to then wait 30 days, then you have to send it back to our laboratory. The shipping time takes a little bit to get to our laboratory. We need a couple of days in order to do the analysis and send a report back to you. And so there's kind of a process. Well, if you have a problem and this problem is invisible and you place coupons, it could be, 30, 45, 60 days before you found out that you have a problem. And so you have to be very careful about the use of these corrosion classification coupons and make sure that you have a really good regimen on using these regularly. Mention to you, though, that we have developed this device, the ECM V2. It's our version 2 of our environmental corrosivity monitor. And this actually has an electronic copper and electronic silver coupon on them, or a sensor on them. And this touchscreen allows you to go through a series of menus and configurations. But the key is this device will give you live readings of your corrosive nature of the air for copper, for silver. It'll also give you your temperature measurement and your humidity measurement, which are very critical in controlling your electronics. Lastly, it also has a room pressure indicator on there. So there's a little tube that you can attach it to. You can run that tube outside of the room, and it'll tell you the difference between the pressure inside and outside the room, and let you know whether you're maintaining a good pressure in the room too. This device has 4 to 20 milliamp output and Modbus communications through Ethernet. You can't see the connection there up on top here. So it's very, very nice device. It's power over Ethernet as well. So it's kind of a plug and play. And you can either use it independently just to have readings on the screen that you can look at live in the room, or you can feed it back to your building control system or your distributed computer system through the Ethernet port, and it can actually pull the device and collect data there. Also, in regard to your adsorbent media, how do you know whether your adsorbent media is being consumed, or how available is it? Is it about to be expired or such? So you can take samples of the adsorbent media, but that's a lot like the corrosion classification coupon. It takes a while. You have to take the sample, send it back to us at the laboratory, and we send it back to you. Our deep bed systems have a device, a real-time media bed monitor that is basically kind of like the dipstick for your car, where you can remove this rod periodically, maybe once a month, and the rod will discolor in the area where the adsorbent media has been consumed. And that allows you to monitor the progression of that discoloration of this monitoring rod and give you an indication of how much life is left in the adsorbent media. So that's for deep bed system. We have actually also developed this technology into an electronic form. We have electronic bed monitor too. We call it our EBM, electronic bed monitor, which goes into the deep bed. So this monitor has a series of sensors which detect the progression of gases through the adsorbent media, goes back into a PLC using our algorithm, and advises the customer when and actually projects out. It gives a prediction of when the adsorbent media is going to need to be replaced. So that's really, really nice. Typically used in odor control systems primarily, but it's a really great technology for knowing, because otherwise, if you don't have any kind of monitoring system, it just eventually the adsorbent media just expires, and you don't know about it until either you find out that your corrosion coupon has gotten really black while you weren't monitoring, or your ECM device here starts triggering off, and suddenly you're in emergency mode needing to replace that adsorbent media. I'll mention too, the ECM, these sensors are sacrificial sensors. We don't recommend putting the ECM into a space until it's protected, because these sensors will corrode quickly in a GX type environment, and they will expire. And so typically these sensors will last for a year or more in a G1 environment. And so we recommend using the coupons to get your space under control, and then implementing the ECM V2 when your space is under control, and basically to make sure that it continues to be in control. So just a little plug for PureAir. PureAir provides a full solution. We help you identify the problems, design appropriate solutions, follow through with implementation, and the key is to monitor the system as well. We've seen a lot of customers in the past, customers of other that have bought air purification systems. They put them in place, and then they kind of forget about them, and years down the road, they don't understand that the system's not functioning any longer. Again, it's invisibly purifying the air, and so we try to work with customers to make sure they understand that concept and they have all the tools in place to be able to do that. So we're entering into our Q&A session. Looks like we've got 80 attendees that attended today. I really appreciate your time. And so let's take a look to see if we got questions in. Yeah, so we have a question coming from the United Arab Emirates. It says, one objection we often encounter is that humidity and temperature control is sufficient to deal with corrosion in control centers, and no need for expensive gas phase filtration. What's PureAir counter argument? Well, I'll tell you this. If we have a customer that has a limited budget and he has humidity problems and temperature problems and problems with gaseous filtration, our recommendation will be to take care of the humidity problem first. Humidity is the biggest problem for protecting electronics. So you've got to get that humidity certainly below, well, preferably below 50%, but just as low as possible. In some areas of the world, like our area of the world, the southeastern United States, is a very, very humid area. It's very difficult to get below 50%, but you want to get that humidity under control. That's your first priority. Once you've gotten the humidity under control, then you can work on gaseous filtration, and you can work on, and typically when you get humidity under control, you're also getting your temperature under control because you're using a cooling or dehumidifying coil to do that. So we would say that's should be your first priority. But I'll tell you this, that's also one of the most difficult ones to do because that involves a lot of HVAC changes. And I can tell you that one of the quickest ways to make a big improvement in your air quality is simply to wheel in a recirculation unit into the room and start recirculating the air inside of the room to remove the gaseous contaminants. So you may not get to G1 immediately in doing that, but you can take a GX environment and you can improve it really quickly to maybe a G2 environment by just bringing in a PureAir recirculation unit, properly sized recirculation unit. So, you know, that's a really great solution, initial solution, all right? Maybe that's not your total solution, but you're going from a really bad situation to an improved situation, and maybe that gives you some time in order to put a more permanent solution in place with dehumidification and temperature control. So thank you very much for that question. That was very good point coming from the UAE. Wanted to check any other questions? All right. Well, I think that was it. I really appreciate your time today. Very pleased by the attendance today that we had for it. Certainly shoot us a note, ask any kind of questions that you might have. This presentation is available to you if you'll just send an email. Our email info@pureairfiltration.com is a great email to send general inquiries to, and you're of course welcome to send me a note, kjameson@pureairfiltration. Thanks for your time today, and let us know how we can assist you.